Hello, good morning dear students. So in the previous class we learned about solving the problems based on Pythagoras theorem and similarly how to prove the opposite sides are equal and also if the parallelogram circumscribing the circle then it forms a rhombus. And in this class we are going to learn two important theorem. In these two theorems, one will come for the final exam for 3 marks. Okay, so very important theorem. The first theorem. Just listen carefully. Theorem 1. The statement is the tangent at any point, the tangent at any point of a circle is perpendicular to the radius to the radius through the point of contact So I will write the statement once again. The tangent at any point of a circle is perpendicular to the radius through the point of contact. So what we have to prove? We have to prove the tangent is perpendicular to the radius at the point of contact. The point of contact means the point where the tangent touches the circle. Okay, so that is called as point of contact. And for that we will consider one small diagram. So here we have to go step by step. First we have to write what are the given data, then what we have to prove and what the construction we are going to do while proving, and after that we have to write the proof. Okay, so the tangent at any point of a circle, I will consider one point as P and I will consider the center as O. Center is O, then point of contact is P, and now I will draw one tangent to this circle. I will call the endpoints as X and Y. I will join point O and P because it is given that the tangent is, we have to prove the tangent is perpendicular to the radius. So here tangent is xy, OP is the radius and P is the point of contact. First we will start. First, given a circle of center at O, xy be the tangent to the circle at point of contact P, at point of contact P. So this is a given. Okay, and we can write OP is the radius. OP is the radius. Next, what we have to prove, that one we have to write here. To prove, given, then this is to prove, we have to prove OP is perpendicular to XY. OP, we have to prove OP is perpendicular to XY. Now, to prove OP is perpendicular to XY, we have to consider some assumption. Okay, for that, I will take another step, that is construction. Mark a point Q. Mark a point Q on the tangent line XY. Mark a point Q on the tangent line XY. I will mark one point here, and that point is Q. Next step, join point O and Q. Join point O and Q. I will join the 2 points. Okay. And I will mark this point as R. I will mark the point as R. Next, proof. Okay. First, we have to write a statement. The statement is the tangent at any point of a circle is perpendicular to the radius through the point of contact. We have to prove the tangent is perpendicular to the radius. That one we have to prove. For that, first we have to draw the diagram. Okay, simple circle with center O and XY as the tangent at the point of contact P. So that is the initial step. After that, we have to write the given. What are the given data? So circle is drawn with the center O and XY be the tangent to the circle at the point of contact P, and OP is the radius. Because OP radius, because the line joining the center and any one point of the circumference of the circle, that forms a radius. Therefore, OP is the radius. Then next step, what we have to prove, that one we have to write. To prove OP is perpendicular to XY, that means radius is perpendicular to tangent, or tangent is perpendicular to radius. The next one, for that proof, we have to mark one point Q on the tangent XY, and we have to join OQ, and we have to join point O and Q. How many of you understood this? So this is initial step. So this is a very simple theorem, but it carries nearly 2 or sometimes it carries 3 marks. Very, very important and simple theorem. Next, here let's consider point R on the circumference of the circle circumference of the circle. When we consider a point on the circumference of the circle, see here, this is point R, and the line joining the center and point on the circumference of the circle, that is R, it forms again a radius. Therefore OR is also radius of the circle. OR is also radius of the circle. And Q is the point which is outside the circle. Q is the point which is outside the circle, which is outside the circle. When we consider a point which is on the circumference of the circle, that length is less when we compare that with the line where the point is outside the circle. Just see the diagram here. When you compare OR and OQ, which is larger? Comment me first. When you compare line OR and line OQ, which is larger distance? First, which length is larger? OQ is the largest distance. So therefore OR is less than OQ. OR is less than OQ means OQ is the greater one, and this implies OP is less than OQ. OP is less than OQ, and the shortest distance forms the perpendicular for the circle. So therefore OP is the shortest distance, shortest line. Therefore OP is the perpendicular for the tangent xy, Okay, the statement is the tangent at any point of a circle is perpendicular to radius through the point of contact. So therefore, hence prove. So this is about the first theorem. Very important theorem. How many of you understood this? Then next one. So next is on the length of the tangent. Okay, from an external point we can draw two tangents to the circle, and now we have to prove the tangent drawn from the external points are having equal length. I'll write the second theorem statement. Theorem 2. The length of the tangents, the lengths of the tangents drawn from an external point, to a circle are equal. The lengths of the tangents drawn from an external point to a circle are equal. Okay, for that first I will draw one small diagram. So I will consider the center of the circle as O, and it is given that the lengths of the tangent drawn from an external point. I will consider one external point, that as P, and now I have to draw two tangents to this circle, from this external point P. Similarly on the other side, so I will mark the endpoints as Q and R. Okay, this is the initial step we have to consider for the proof. First we will write the given term. First is given. Okay, I will repeat the statement once again. The lengths of the tangent drawn from an external point to a circle are equal. We have to prove PR equals to PQ. We have to prove PR equals to PQ. So first, given, consider or given, okay, consider or given a circle with center as O, then P is an external point, and two tangents are drawn. One is PQ and another one is PR. One is PQ, one tangent, and another one tangent is PR. Okay. The next, what we have to prove? To prove, this is second statement. The second step, we have to prove PQ equals to PR. So we have to prove PQ, length of PQ, that is equals to length of PR. We have to prove. Then for this we have to do some construction. Okay. Join point O and Q, then join point O and R, join point O and P. These are the 3 points. That means we have to draw 3 lines now. We have to join point O and Q, it forms one line. We have to join point O and R, it forms another line. And next we have to join point O and P, it forms another line. Okay, we will join that in the figure. First one, point O and Q. Then similarly O and R. The next one is O and P. Okay. Now proof. How many of you understood this up to now? Till now? Comment your name first and click on the like button. So the length of the tangent are equal. That one we have to prove here. For that we have to first draw the diagram. Then we have to write the given data. The given data are circle of radius or center O, and P is an external point, and two tangents are drawn, and they are PQ and PR. Next, to prove, what we have to prove, we have to write, that is we have to write we have to prove PQ equals to PR. The next construction, we have to join point O and Q, and we have to join point O and R. Also we have to join point O and P. Okay, next proof. Next one, proof. Consider triangle. Consider triangle OPQ. Consider triangle OPQ and triangle OPR. See here, triangle OPQ, that means the upper triangle. Then second one OPR. OPR, this next triangle. Now we proved the triangles are equivalent by using SSS, that is side criteria, then ESA, then SAS, similarly RHS theorem. So any one we have to consider. Now I will consider. So because in the previous theorem we proved that the tangent is perpendicular to the radius. Okay, in the previous theorem we proved that tangent is perpendicular to radius. So therefore these two triangles are perpendicular triangles. Okay, or right angles triangles. So for that we can use RHS theorem. Okay, RHS theorem. So for that we need the triangles must be right angle. So here two angles are equal to 90 degree. So therefore first property holds good. Then so the hypotenuse side, that is OP, this is 90 degree. So see here, if this is equals to 90 degree, then hypotenuse sides are equal because OP is the common side. And apart from that, any one side of the triangle. So we can consider OQ and OR. OQ and OR. I will write here. Okay. OQ and OR, because they are radius of the circle. Therefore, triangle OPQ, that is equivalent to triangle OPR. Okay, first one, both the angles are equal to 90 degree and the hypotenuse side, that is OP, that is common side for these two triangles, and OQ and OR are the radius. The radius of the circles are equal. Okay, from that we can write triangle OPQ is equivalent to triangle OPR. First we will write that OQ equals to OR, because radius of the circle. The next one, OP equals to OP. Reason is common side. Reason is common side. The next one is angle OQP, and that is equals to angle ORP, that is equals to 90 degree. Reason is tangents are perpendicular. Tangents are perpendicular to the radius. Perpendicular to the radius. So therefore triangle OPQ is equivalent to triangle OPR. So which theorem? RHS theorem. RHS theorem. So this implies, so when these two triangles are equivalent, then the remaining sides and angles of the triangles are also equal. That is according to CPCT rule, corresponding parts of congruent triangle. So here we proved that triangle OPQ is congruent to triangle OPR. Okay, triangle, we proved that triangle OPQ, that is congruent to triangle OPR. When the two triangles are congruent, then the remaining sides and angles of the triangles are also equal. So that is according to CPCT rule, corresponding parts of congruent triangles. So therefore we can write, this implies PQ equals to PR. CPCT rule, corresponding parts of congruent triangle. Okay, just look at the step. How many of you understood this? This is very important theorem. First, the next one, okay, these are the two very important theorem. Apart from this, I'll solve another problem of exercise 2, that is prove that the perpendicular, prove that the perpendicular at the point of contact, at the point of contact to the tangent to a circle passes through the center, Okay, now for that, what we have to prove? We have to prove the perpendicular drawn to the tangents is passing through the center of the circle. For that, I will draw one small circle here. I will consider the center as A, and I will draw one tangent for this circle. I will mark this point as P, this as X, this as Y. Next one, let A be the center of the circle, and XY is the tangent, at the point of contact, P, okay. Next, what we have to prove? We have to prove the perpendicular which is drawn to the tangent is passing through the center of the circle. That one we have to prove. We have to prove, or directly to prove perpendicular at the point of contact, perpendicular at the point of contact, at the point of contact passes through the center, okay, or center of the circle. That one we have to prove. For that, I'll consider one small assumption. Let's consider point B. I'll consider one point B, which is not the center, which is not a center, and perpendicular to the tangent, and perpendicular to the tangent. So what we have to prove? We have to prove the tangent, the perpendicular drawn to the tangent as passing through the center we have to prove. But I will consider one point B which is not the center of the circle, but it is perpendicular to the tangent. That is small assumption. For that, I will join point OP, and similarly I will join point AP. So when that is perpendicular, then angle BPY, that is equals to 90 degree. BPY, that is equals to 90. Assumption. But we know that, so in the previous theorem, but we know that perpendicular to the tangent is radius, and radius passes through the center. Okay, it joins the center and circumference, or point on the circumference of the circle. Therefore, angle APY, that is equals to 90. Angle APY, that is equals to 90. That is because of the theorem, and this is because of assumption. That is angle BPY, that is equals to 90 degree. That is because of assumption. So therefore, angle BPY equals to 90 degree only when point B coincides with point A. So when point B coincides with point A, then only the angle PBY. So this is not angle. Now it reached the point A, or it overlaps on the point A. Then again it becomes BPY, that is equals to 90 degree. Okay. This is the case when B overlaps on point A. Hence, BP is also passes through the BP is also passes through the center of the circle. How many of you understood this? Just comment your name first. So it is another form of the first very simple one. So now we learned the perpendicular drawn from the tangent passes through the circle, and then the length of the tangents drawn from an external point to a circle are equals to each other. And similarly another theorem, that is the tangent at any point of a circle perpendicular to the radius through the point of contact. Okay, I think everyone understood this. Thank you everyone. I'll continue in the next class.